Hello, welcome to another episode of the U. One of the challenges with static routes is there's no built-in mechanism for checking if the route is up or down. If the next hop gateway becomes unavailable, the route can still remain in the table. The only way that the route gets removed from the table if the associated interface on the Cisco secure firewall gets down. The static route tracking feature is a way of monitoring the route and installing a backup if the primary route becomes unavailable. In this demonstration, we're going to start by examining the primary and static backup routes. We're going to show how the static route remains in the routing table when the next hop gateway becomes unavailable. We're going to define a service level agreement monitor object and associate that with the primary route using the route tracking feature. And then finally show how the static route is removed from the routing table when the next hop gateway becomes unavailable. So let's take a look at the demonstration environment. As you can see here, there are three devices that we set up static routing for. We have the Cisco secure firewall, denoted by FTD, which is connected to the general network. And then we've got two other routers. We've got CSR2, that's a CSR 1000 virtual router, which is connected to Bladder. And we've got CSR3, which is connected to the remote network. Now, on each of these networks, we've got a host. There's a tiller on the general network, Bladder on the DMZ, and we've got the host remote on CSR. These are VMs, actually Ubuntu. So let's move over and see these in action. Okay, so here we've got the first of all the host tiller, which you just saw from the diagram. And if I try and communicate with a host in a different zone, you can see that that's working just fine. And if I check the path of that packet, you can see that it's going through the subnet 0 interface 10002, as we saw from the diagram a short while ago. Let's take a look at the Cisco secure firewall, which is here. And if we go to the device management menu and click on the pencil symbol to edit, and then go to the routing tab, and here we can see the static routing, which is just here. What we can see here is that there are a number of static routes, but the one I'm going to focus on is one for the DMZ. And you can see that the primary route to the DMZ is this one here. And it's got a metric of 1. This is important. And the gateway is CSR2. And there's a secondary or backup static route for the DMZ. This one going through CSR3, and that's got a metric of 2. So if I go back and take a look at the Cisco Secure Firewall console, which is here, okay, and I can test this as well. So if I do a ping of 192.168.10.90, you can see that that's working okay. And I can do a trace route of 192.168.10.90, like so. Now, if I take a look at the routing table on FTD with this command, show route, in particular here, you can see that this target to the 192.168.10 network, the DMZ, it's using the primary route. But if I run this other command, that's a show running config, and let's take a look at the routes which have been set up. Then you can see, just as we saw in the GUI, that this 192.168.10 network, we've got the last figure there is the metric So there's actually two different routes. There's a primary and secondary route. Each of those is going through a different interface. Okay, now here I've got the CSR2 router, and if I type in here, show IP, view the routing table here, then we can see the routes for this host and show running config. And then I can see again, the primary and secondary route for different interfaces here. The last number there is showing the metric. Now to simulate a problem, you can see that Ethernet 2 interface. So if I go and just simulate a potential problem, so interface E2, now I can see that interface is administratively down. I go back to Attila, and that can no longer, trace path isn't working, the ping stops working. But if I take a look at FTD, the Cisco Secure Firewall, view its routing table, you see that it's still trying to send to this interface, even though that gateway is no longer available. Okay, but if I go to the other router, CSR3, which I haven't really introduced before, I can still ping that host like so, and I can do that because it's taking a different path, 192.168.10.90. Okay, so that's actually just working fine, 192.168.10.90. So let's go back and re-enable that interface. Okay, and now go back to here. That ping should start working again. When that interface is up, it should start working shortly. There we go. And so what can we do about that? So what we can do about it is we can define this service level agreement object. And the way we do that is we go to object management. And in this list of objects, you'll find one of those is this SLA monitor. And I've actually already defined this. Now, when you define this object, this doesn't exist by default. You identify the object you want to monitor. This one I've called letter. The fields with the asterisk you have to enter. So you put in a monitor ID. You can specify how frequently you want to test. So how quickly do you want to denote a change? How many packets? And importantly, you have to put in the address of the host. Well, we saw from the map that is the address, and here's the zone. There are other fields you can enter there. If you click on the question mark, you can get much more information about this. So that's the important thing. Once you define the object, you go back to your device management. And what I can do now is go back to my static routes. Okay, now for this DMZ, and this is importantly not for the secondary route, but for the primary route, what I'm actually going to do is to edit that. And I'm going to add this route tracking. And very simply, if I haven't defined the object, I could define it here. I've already done that in object management. And what I'm going to say is that I'm going to monitor, just check for this route that this host is available. And if it isn't, I'm going to remove that route from the routing table. Now, once I've done that, I have got to save and then deploy. Now, this deployment will take a little while. Okay, so there's not much I can do about that, but fine. So let me just go back and verify. I think this ping was working. Yes, it is. Okay, that's good. And if I go back here, and let's check the routing table, and you can see that for 192.168, we're using, the metric is 1, we're going via 10.0.0.2. Now that's actually working. Okay, so what I'm going to do here is to go and do that ping. That is working. But if I go back to CSR2 once again, now if I shut down this interface and verify that it's down, that interface is down, go back to here and do a ping. Okay, that ping stopped temporarily, but if I try again, you see the ping is working. But if I trace a path, it's going a different direction. And if I go back to here, you can actually see, before I enter the command again, that here the next hop was 10.0.0.2. And if I run that again, now the next hop is via 10.0.0.6. And you can see the metric there is 2. Okay, so that's basically the end of this demonstration. So in summary, static routes, there's no built-in mechanism for removing that entry if it's not available. If you have a Cisco secure firewall, if the interface itself goes down, then it removes that table. But if you want that dynamic mechanism, by making use of this route tracking using a service level agreement object, monitor object, as just demonstrated, you can do that. Thank you for watching this episode of The U. Hope to see you in another episode.